Champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. So today we are going to deal with chemistry questions from NEET paper 2017 and we are 45 questions here. So let's start the session. The first question is related to oxidation states and the question is name the gas that can readily decolorize acidified potassium permanganate solution. Okay. So what does it mean by decolorize acidified potassium permanganate? It means that it should be able to reduce the acidified potassium permanganate. Okay. And when it will reduce the potassium permanganate, it will itself get oxidized, right? So it will get itself oxidized. And we know that in case of oxidation, the oxidation state increases, isn't it? That means the oxidation state of the central atom should increase, right? Now let's try to find which of the given options will be the correct answer. So first we'll take the first option, that is SO2. SO2. Here let's find the oxidation state of sulfur. Suppose this is X, then X minus 4 because each oxygen atom has minus 2 oxidation state. So X minus 4 equals to 0. So X will be equal to plus 4. Okay. That means the sulfur has the oxidation state plus 4 in this case. So can the oxidation state of sulfur increase? Yes, it can increase because it can go up to plus 6, right? So this is possible. Now let's take the second option, that is NO2. Here again X minus 4 equals to 0. So the oxidation state of nitrogen will be plus 4 again. Can it further increase? Yes, it can increase. It can go up to plus 5. So this is also possible. Now if we take the third option, that is P2O5. Here let's say that X is the oxidation state of this phosphorus. Then it will be 2X minus 2 into 5 will be minus 10, right? So minus 10 equals to 0. So here X will be equal to plus 10 divided by 2, that is plus 5. Now can this further increase? No, it cannot increase because plus 5 is the maximum oxidation state of phosphorus. So this is not possible. Okay, this cannot further increase. That means it will not get oxidized. Now if we come to the last one, fourth option, carbon dioxide. Again X minus 4 equals to 0. So X equals to plus 4. Now this is also not possible because carbon has maximum oxidation state as plus 4. So this will also not further increase. Now we have only two possible options, that is SO2 and NO2. Now we know that in case of nitrogen, the maximum oxidation state is plus 5. So it can increase by plus 1. Okay, here it is plus 4, so it can increase by 1. In case of sulfur, the maximum oxidation state is plus 6, so it can increase by 2. That means sulfur will have more tendency to get oxidized. Okay, sulfur will have more tendency to get oxidized as compared to the nitrogen. Therefore, it will be able to readily decolorize the potassium permanganate solution. That means it will be able to reduce the acidified potassium permanganate solution. Okay. So the correct option will be option number A. Question number 47 is from chemical kinetics and the question is mechanism of a hypothetical reaction x2 plus y2 gives 2xy is given below. So here we can see that 3 steps are mentioned and the overall order of the reaction is asked. Okay. So we can see that 2 steps are fast and 1 is the slow one. And we know that the rate of a reaction depends on the slowest step, right? Rate of a reaction depends on the slowest step. So here the slow step is the step 2. So what are the reactants here? X and Y2. That means the rate of a reaction will depend on the concentration of these two reactants, right? So rate will be proportional to the concentration of X and concentration of Y2. If we put the constant, we can write R equals to K concentration of X into concentration of Y2. Now, from the first step, that is the fast one, we can find the concentration of X and then we can put in this equation. Okay, let's say this is equation number 1. Now on this side, let's use the first step. From step 1, we can say that K equilibrium will be equal to the concentration of products, that is X into X, divided by the concentration of reactant, that is X2. Okay, so K equilibrium into X2 will be equal to concentration of X square. Now we can find the concentration of X as by finding the root of this, right? So that will be equal to the concentration of X. Now root can be written like this: K equilibrium to the power half into X2 to the power half, right? So this is the value of concentration of X. Now we can put this in this equation, right? We can put this here. Putting the value of concentration of X in the above equation, we get rate is equal to K into concentration of X is what? K equilibrium to the power half into X2 to the power half into concentration of Y2. Okay, so this is the value of concentration of X that we had obtained, right? Now here K and K equilibrium both are constants. Okay, so this complete expression, okay, let's assume that K into K equilibrium to the power half is equal to K dash. Okay, we'll take it as a single constant. Okay, so rate will be equal to K dash into X2 to the power half into Y2. So from this we can find out the order of the reaction, right? Order of the reaction. What is the power on X2? It is half, that is 0.5. And what is the power on Y2? It is 1. So the overall order will be 1 plus 0.5, that is 1.5. Okay, so option C will be the correct answer. Now question number 48 is from the chapter Classification of Elements and Periodicity in Properties, and the question is: the element with atomic number 114 has been discovered recently. It will belong to which of the following family or group, and what will be the electronic configuration? Okay, so the answer is that the recently found element with atomic number 114 is flerovium. And it belongs to group 14 of the periodic table. Group 14, that is which family? Carbon family. So out of the given options, only option A is possible because carbon family is mentioned in this option only. Okay, and this is the electronic configuration of flerovium. So option A is the correct answer. Question number 49 is from the chapter Alcohols, Phenols and Ethers, and the question is: the heating of phenyl methyl ethers with hydrogen iodide produces, options are iodobenzene, phenol, benzene and ethyl chlorides. Okay, so let's write down the reaction first. We have phenyl methyl ethers, that means this is the phenyl, that means the benzene ring. Then here we have oxygen and this side we have methyl group. Okay, so this is phenyl methyl ether and it has to react with hydrogen iodide. So we have to find out the product. Now let's see what are the possibilities here. When this reaction takes place, either this bond will break or this bond will break, right? Let's say this is bond number 1, this is bond 2. Now we know that oxygen will have lone pair of electrons. So due to this, these lone pair of electrons, bond 2 will have double bond character. Okay, this bond will have double bond character. So this bond will be stronger as compared to bond 1. Okay, so this will be difficult to break. So bond 1 can easily be broken. So this is the bond that will be broken. Okay, bond 1. So let's see. This is the benzene ring. Here oxygen will remain attached to this ring and this bond will break, right? So let's see what will get attached here. Plus this side we have methyl and this side something else will get attached. So we have hydrogen iodide, hydrogen will get attached here and iodine will get attached to the methyl group. So what are the products that we have obtained? We have obtained a phenol. This is phenol and this is methyl iodide. Methyl iodide. So in the given options, methyl iodide is not mentioned. So phenol will be the correct answer. Option B is the correct answer here. Now question number 50 is from the chapter Organic Chemistry, some basic principles and techniques. And the question is, which one is the correct order of acidity? So this is a simple question and the fact is that the order of acidity is determined by the S character. Okay. So we know that as the S character increases, as S character increases, acidity also increases. Okay. That means here in SP, we know we have 50% S character, so this is maximum. Then SP2 and then SP3 is has the least S character. So same will be the order of acidity as well. That means alkynes will be most acidic, then alkenes and alkanes will be least acidic, right? Now, if we check in option A, first we have an alkyne and all the carbons here are sp hybridized, okay? So this will have maximum acidity. Then the next one, first one has sp3 hybridization, but other two carbons are sp hybridized. That means this is a correct order. In the third one, we have an alkene. Okay, so this is sp2 hybridized, and the last one is an alkane. So sp3 hybridization is there. That means this is a correct order of acidity. That means option A will be the correct answer. Okay. Now question number 51 is from hydrocarbons and the question is predict the correct intermediate and product in the following reaction. So we can see that the reactant is an alkyne. In fact, it is an unsymmetric alkyne, right? So let's write down the reaction here. CH3, C, triple bond, CH, okay? And it is reacting with H2O, that means water. So hydration will take place. Then we have H2, SO2 and then Hg, SO4. So we know that hydration has to take place. So OH minus ion will get attached to one of the carbons of this alkyne, right? So to which one of the carbons will this get attached? So that will be determined by the Markovnikov rule. Okay, Markovnikov rule. So what does this rule say? According to this rule, the negative part of the reagent, gets attached to the carbon having fewer hydrogen atoms. Okay, having fewer hydrogen atoms. So we can see that in this alkyne there are 3 carbons and out of these 3 the middle one has no hydrogen. So this OH minus will get attached to this carbon, okay, according to the Markovnikov rule. So an intermediate will be formed, that is CH3 COH, and this side we have double bond CH2. Now here we have a double bond, that means an alkene, and we have an alcohol also, OH. So this is known as enol form. Okay, this is the enol form. And this is the intermediate A that will be formed in this reaction. So we can look at the given options. The first one is, here you can see that here the carbon is making 5 bonds total. So this is not true. Okay. In the second one, this is a ketone. So this is not true. In the third one, we have enol, and this is the same that we have drawn here. So yes, this is correct. Okay. So option C, from the first part only, it is clear that option C is the correct answer. Fourth is also not correct. We don't have sulfate here. But still we'll find the final product also. Now we know that oxygen here will have a lone pair of electron, right? So delocalization of electron will take place, and due to that tautomerism will take place. Tautomerism. Have you heard of the word tautomerism? What is tautomerism? This is a phenomena by which a compound can exist in more than one form. Okay. So this compound will exist in two forms. First is enol form and the second one will be keto form. Okay, so let's draw the keto form. Due to the delocalization of electron, it will exist in the keto form as well. So this is the keto form. Okay, now here out of these two, the keto form will be more stable form, and due to this is considered as the major product or the final product, right? And the enol form is considered as the intermediate. So this is the final product. So we can see that in the third option only the final product is a keto form. Okay, the intermediate is an enol form and the final is keto form. So option C will be the correct answer. Question number 52 is from the chapter Chemical Kinetics, and the question is the equilibrium constant of the following are. Okay, so three different reactions are given and their equilibrium constants are given as K1, K2 and K3 respectively, and we have to find the equilibrium constant K of this reaction. 2NH3 plus 5 by 2O2 gives 2NO plus 3H2O. Okay, now what we have to do here, we basically have to use the above three reactions in order to get this final reaction. Okay, so if we look at the first reaction here whose equilibrium constant is K1, let's say this is reaction number 1. So here we can see that ammonia 2NH3 is on the product side, but in this final reaction whose equilibrium constant we have to find, here the 2NH3 is on the left hand side, that means on the reactant side. That means we have to reverse the first reaction. Okay, so the first one will be reversed and it will become 2NH3 and this side will have N2 plus 3H2, right? So if we reverse this reaction, then its equilibrium constant will also be inversed, right? So it will become 1 by K1, right? 1 by K1, this will be the equilibrium constant of this reversed reaction. Now, second reaction. Here we can see that 2NO is on the product side and in the final reaction also 2NO is on the product side. So we'll write this reaction as it is. So N2 plus O2 gives 2NO. So its equilibrium constant will be K only, K2 only. Okay. Now the third one. In the third one, H2O is on the product side and in the final reaction also H2O is on the product side. But here we have 3 times H2O, right? So we'll multiply the third reaction, this one, with by 3. Okay. So it will be 3H2 plus 3 into 1 by 2, that means 3 by 2O2. And it will give 3 molecules of H2O, right? And its equilibrium constant will be K3 to the power 3, right? Because when we multiply this reaction by 3, then its equilibrium constant will have power 3, right? Now we'll add these 3 in order to get the final reaction. So here N2 will be cancelled, right? Then we have H2, 3H2 will be cancelled. So what is left on the left hand side? Here we have 2NH3, then we have O2 plus 3 by 2O2. So it will become 5 by 2O2. Okay. Adding these two will get 5 by 2O2. And on the product side, we have 2NO plus 3H2O. So isn't this reaction the same as this mentioned in the question, right? Now the reaction is same. Now we have to find the equilibrium constant of this reaction by using the above 3 equilibrium constants. So it will become what? K1 is on the denominator side. So it will be here. Then K2 is on the numerator side, this side. And then we have K3 to the power 3. Okay. K3 to the power 3. So this will be the equilibrium constant of this final reaction. So let's see which option has this. K2 into K3 cube upon K1. So option A is the correct answer. Question number 53 is from the chapter Organic Chemistry, Some Basic Principles and Techniques. And the question is, which one is the most acidic compound? Okay, so what does the acidic character of a compound depend on? It depends on different types of effects. Let's write it down here. Acidic character. So this is directly proportional to minus M effect and it is directly proportional to minus I effect as well. M means mesomeric effect and I means inductive effect. But it is inversely proportional to plus M as well as plus I effect. Now we know that different groups will show different types of effects. Let's check one by one. In the first option, we have a simple phenol. That means no additional group is present on the ring. So it will be moderate, right? If we come to the second option, here we have one nitro group, NO2. And we know that NO2 is an electron withdrawing group. Electron withdrawing group. That means it will show minus M effect. So we know that acidic character is directly proportional to minus M effect. So definitely it will be more acidic as compared to the first one. Okay. Now if we look at the third option, here we have three NO2 groups and we know that NO2 is electron withdrawing and it will show minus M effect. So there are three NO2 that are showing minus M effect. So it will be definitely more acidic than the second one. Okay. So out of the three, it will be most acidic. If we talk about the last one, here we have a methyl group CH3 and CH3 is an electron donating group. Okay, electron donating group, and it will show which type of effect? It will show plus I effect. That means it will be least acidic among the four options because acidic character is inversely proportional to plus I effect. Therefore, the correct option is option C. This is the most acidic compound. Question number 54 is again from organic chemistry and the question is the correct increasing order of basic strength for the following compounds is. Okay. So in the previous question we discussed the order of acidic strength and here the question is asked about the order of basic strength, right? So we'll use the same method. We know that in the previous question we saw that acidic character is directly proportional to minus M effect and minus I effect. Okay, and it was inversely proportional to plus M and plus I effect, isn't it? Similarly, the case will be just the opposite for basic character. That means basic character will be directly proportional to plus M and plus I effect and it will be inversely proportional to minus M and minus I effect. Okay. And we are aware that M means mesomeric effect and I means inductive effect. So here we have to focus on this relation. Now, in the first option, we have an aniline or aminobenzene. So no additional group is attached to the ring. So it will be of moderate nature. In the second option, we have a nitro group. We know that nitro group, NO2, is an electron withdrawing group. Electron withdrawing group. So it will show which type of effect? It will show minus M effect. So we have seen that basic strength is inversely proportional to minus M effect. That means it will be less basic. Okay. So it will become less, it will make the compound less basic. Now in the third option we have a methyl group CH3 and we know that methyl group is an electron donating group. And it will show which type of effect? Plus I effect. And we can see that basic character is directly proportional to the plus I effect. So it will make the compound more basic, right? More basic. That means third one will be most basic here. So we have to arrange them in increasing order of the basic strength. That means the third one will be most basic, right? Then first one is the moderate and least basic will be the second one. So this will be the sequence 2, then 1, then 3. So according to that, option C should be the correct answer. Question number 55 is from the S block elements and the question is ionic mobility of which of the following alkali metal ions is lowest when aqueous solution of their salts are put under an electric field. Options are potassium, rubidium, lithium and sodium. So all of these are alkali metals. Let's list down the alkali metals. We have lithium. Then if we move down the group, the next atom will be sodium, then potassium, then rubidium and at last cesium. and these are in increasing order of their atomic size from lithium to cesium, right? So same will be the order of ionic size. That means lithium ion will be of smallest size, then sodium ion, then potassium ion, then rubidium ion, and then cesium ion, right? Now we know that smaller the ionic size, greater will be the hydration. So greater will be the size of hydrated ions. Let's write it down here. Smaller the ionic size, the ionic size, greater the hydration. Okay. Hence, greater will be the size of hydrated ions, right? Of hydrated ions. That means here we can see that the smallest ionic size is for lithium ion, right? Lithium ion has smallest ionic size among all the alkali metals. That means it will have maximum hydration. So it will have the maximum size of hydrated ions. Okay, so it will be having greatest size of hydrated ion among all the alkali metals. Now, here the question is asked about the lowest ionic mobility. So, ionic mobility is inversely related to the size of hydrated ion. Okay, size of hydrated ion. So since lithium has maximum size of hydrated ion, so it will have lowest ionic mobility, right? Therefore, lithium ion will have lowest ionic mobility. And this is what is asked in this question. So our correct option will be option C, that is lithium. Okay. Question number 56 is from the chapter Organic Chemistry, Some Basic Principles and Techniques. And the question is, the most suitable method of separation of 1:1 mixture of ortho and para nitrophenols is, options are chromatography, crystallization, steam distillation and sublimation. And the correct option will be option C, that is steam distillation. Okay. What is the reason? The reason is that one of them is more volatile and the other is less volatile. So let's write it down here. The orthonitrophenol, this one is more volatile. Okay, this is steam volatile. And what is the reason? The reason is the intramolecular hydrogen bonding. Okay, intramolecular hydrogen bonding. There is no intermolecular bonding, so it can easily be vaporized. Okay, then the next type, that is para nitrophenol is less volatile, and the reason is the presence of intermolecular hydrogen bonding. Intermolecular hydrogen bonding. So the molecules will be more closely associated with each other. Therefore it will be difficult to vaporize them, right? So what will happen when we perform steam distillation? More volatile, that is orthonitrophenol, will get vaporized first and it will be collected separately, right? So this way they can be separated. So option C will be the correct answer. Now question number 57 is related to D and F block elements, and the question is HgCl2 and I2, both when dissolved in water containing iodide ions, the pair of species formed is. Okay, so let's see one by one. First one is HgCl2. Okay, now it will react with iodide ion present in water. Okay, so iodide ion, that is I minus. So let's see what is formed here. It will form HgI2 plus Cl minus. Okay, when we balance this reaction, it will be 2I minus here, and 2 Cl minus here. So what is formed? HgI2, and it will further react with I minus, and finally it will form HgI4 2 minus. Okay. Now the second one, that is I2. It will also react with iodide ion. So it will simply form I3 minus. Okay. So one of the species is HgI4 2 minus and the other is I3 minus. So the correct option will be option number B. Okay. Question number 58 is from the chapter Chemistry in Everyday Life, and the question is mixture of chloroxylenol and terpineol acts as, options are antiseptic, antipyretic, antibiotic and analgesics. So these two, chloroxylenol and terpineol, are the constituents of Dettol. Okay, we all use Dettol at our homes. We know that it acts as an antiseptic, right? Therefore option A will be the correct answer. Now question number 59 is from haloalkanes and haloarenes, and the question is an example of sigma bonded organometallic compound is, options are Grignard's reagent, ferrocene, cobaltocene and reutenosine. So the correct answer is option A, that is Grignard's reagent, because other three options are pi bonded, not sigma bonded. Okay. Grignard's reagent will be the sigma bonded organometallic compound. And what is the formula? Suppose this is alkyl group R, then here we'll have CH3MgX, okay, attached to an alkyl group, and X will be any halogen. So this is sigma bonded. Now if we talk about the other options, ferrocene. So what is the structure of ferrocene? Let's see. This is a pentagon, right? Then one more pentagon here, like this, and then there will be a ferrous between them. Okay, so this is ferrocene. Now cobaltocene will have the same structure, only in place of ferrous we'll have cobalt, and in case of reutenosine we'll have ruthenium here, okay, in place of ferrous, and other things will be same. So here how it is pi bonded, see, when resonance will take place, then it will get converted into a pi bond. Okay, this bond between these two rings will get converted into pi bond. So we can say that there will be pi bond formation through the resonance here. Therefore it will not be sigma bonded compound, but it will be pi bonded compound, right? Therefore option A is the correct answer. Question number 60 is from the chapter Chemical Kinetics, and the question is, a first order reaction has a specific reaction rate of 10 to the power minus 2 per second. How much time will it take for 20 grams of the reactant to reduce to 5 grams? Okay, so what is given here, the specific reaction rate, that is K, is given as 10 to the power minus 2 per second. Then the initial concentration, that is A naught, is given as 20 grams. It has to reduce to the final concentration, that is AT, and it is given as 5 grams, right? And we have to find out the time taken for this reduction. So now we have a simple formula, T equals to 2.303 upon K log A naught by AT. Okay. Now we simply have to put the values. So 2.303, here K is 10 to the power minus 2 per second, log initial concentration is 20 and final concentration is 5. So here we'll get log 4. So we can write it as 2.303. So this 10 to the power minus 2 will go up as 10 to the power 2, or we can write 100. Okay. And log 4 can be written as log 2 square, right? 4 is equal to square of 2. So here 2.303 into 100, that means 230.3, and log 2 square, let's see, log 2 square, that means 2 log 2, and the value of log 2 is approximately 0.30, so it will be equal to 0.60. okay, approximate value. So here we can write 0.60. Now on multiplying this, we'll get 138 point something. So out of the given options, we have only one option that is closer to it, that is 138.6. So we can write that 138.6 second will be the correct answer out of the 4 given options. So it is the correct answer. Okay. Now question number 61 is from the chapter Chemical Bonding and Molecular Structure, and the question is match the interhalogen compounds of column 1 with the geometry in column 2 and assign the correct code. Okay, so the first one in column 1 is XX dash, so only two atoms are there, right? So what shape is possible by two atoms? Only linear shape is possible. So the correct match for A will be number 3, that is linear. Okay. Then the second one is XX-3. So total 4 atoms are here. So the correct match for this will be number 1, that is T shape. Okay. What happens in T shape? There is one central atom and 3 surrounding atoms. That means total 4 atoms. So the correct match for B will be number 1. Third one is XX-5, that means one central and 5 surrounding, so total 6 atoms, right? So the correct match for this will be square pyramidal, right? Here we have one central atom and 5 surrounding atoms, so total of 6 atoms are there in case of square pyramidal. That means the correct match for C will be number 4. Okay, and the last one is XX-7. So one central is there and 7 surroundings are there, total 8. So the correct match for this will be pentagonal bipyramidal. Here we have one central and 7 surrounding atoms. That means total 8 atoms. Okay. So the correct match for D will be number 2. So out of the given options, the correct one is first option. Okay. This is the same match. So option A is the correct answer. The last one that is left out here, tetrahedral. How many atoms are required in tetrahedral? Here we have one central atom and 4 surrounding atoms. That means total 5 atoms are there. Okay. But we don't have any option for this. So this is left here. Option A will be the correct answer. Now question number 62 is from the chapter Equilibrium, and the question is concentration of the Ag plus ions in a saturated solution of Ag2C2O4 is 2.2 into 10 to the power minus 4 moles per liter. Solubility product, that is Ksp, of Ag2C2O4 is. Okay, so we have a solution of Ag2C2O4. Now when it gets dissociated, what will be the ions that we get? We'll get 2 Ag plus ion as cation and C2O4 2 minus as anion, right? So we can see that for 1 mole of Ag2C2O4 we are getting 2 moles of Ag plus ions and 1 mole of C2O4 2 minus. Okay, now if the concentration of C2O4 2 minus is S, then the concentration of Ag plus will be 2S, and same will be the solubility, right? And here what is given in the question, the concentration of Ag plus ions is given as 2.2 into 10 to the power minus 4, and here we have seen that the concentration of Ag plus is 2S. That means the value of 2S is given here. Okay, the value of 2S is given in this question as 2.2 into 10 to the power minus 4 moles per liter. So from here we can find the value of S, that will be equal to 1.1 into 10 to the power minus 4 moles per liter. That is, we have got the concentration of C2O4 2 minus also, right? And same will be the solubility. Now we have to find out the Ksp, that is the solubility product of Ag2C2O4. So that will be equal to the solubility of Ag plus, that is 2S to the power 2, because we have 2 moles of Ag plus, into the concentration or the solubility of C2O4 2 minus, that is S, right? Now the value of 2S is 2.2 into 10 to the power minus 4 square of this into the value of S is 1.1 into 10 to the power minus 4, right? So on solving this, what do we get? We'll get 5.3 into 10 to the power minus 12, right? So this will be the Ksp value. That means option C will be the correct answer. Now question number 63 is from the chapter Electrochemistry, and the question is, in the electrochemical cell, zinc is getting converted into zinc sulfate and copper sulfate is getting converted into copper. The EMF of this Daniell cell is E1. When the concentration of zinc sulfate is changed to 1 molar and that of copper sulfate is changed to 0.01 molar, then the EMF changes to E2. From the following, which one is the relationship between E1 and E2? It is given that RT by F is equal to 0.059. Okay. So what is given here? We have a Daniell cell where zinc is getting converted into zinc sulfate and copper sulfate is getting converted into copper. Okay. Now initially the concentration of zinc sulfate was 0.01 molar and that of copper sulfate was 1 molar, right? And in this case, the EMF of the cell was even. But later on, the concentrations are interchanged. That means the concentration of zinc sulfate becomes 1 molar and that of copper sulfate becomes 0.01 molar. And in this case, the EMF becomes E2. Now we have to find the relation between E1 and E2. So for that, let's write down the reaction first. We have a solution containing zinc plus copper sulfate. And zinc gets converted to zinc sulfate and copper gets converted to copper. Okay, simple. Now we know that the oxidation state of pure element is 0. So here zinc has 0 oxidation state, this side copper has 0 oxidation state. In case of copper sulfate, we know that sulfate has -2 charge, so copper will have +2. Okay, and similarly this side zinc will have +2 charge. So we can see that the oxidation state of zinc is being increased from 0 to +2. That means it is undergoing oxidation. Okay, zinc has been oxidized, whereas the oxidation state of copper has been reduced from +2 to 0. That means it has undergone reduction, or we can say that copper has been reduced, right? Now in order to find the relationship between E1 and E2, first we need to find the values of E1 and E2 respectively, right? So let's write down the formula. We know that E1 will be equal to E naught cell minus 0.0591 upon N. N is the number of electrons transferred, okay? Log concentration of the products, that is zinc sulfate and copper, divided by the concentration of the reactants, that is copper sulfate and zinc. The concentration of pure metals will be considered as unity. So let's cancel these two. So what is left here? E naught cell minus 0.0591 upon N, that is the number of electron transferred, is 2 here, right? So it will be 2 log the concentration of zinc sulfate initially was 0.01, right? And that of copper sulfate was 1. So it will become 1 by 100 here. Let's solve it further. E naught cell minus 0.0591 by 2 log 10 to the power minus 2. Now what will be the value of log 10 to the power minus 2? It will be minus 2 log 10, and log 10 is 1, so it will be minus 2 only. Okay, so we'll put the values here. E naught cell minus 0.0591 by 2 into minus 2. Okay, so 2 will be cancelled and this minus and minus will become plus. So the final value will be E naught cell plus 0.0591. Okay, so this is the value of E1. Similarly, we can find the value of E2. In case of E2, what will happen? The formula will remain same. So the expression will also be same. It will be E naught cell minus 0.059 by 2 log. Here the concentrations will be exchanged, right? So the concentration of zinc sulfate will become 1 and that of copper sulfate will become 0.01. Okay, so it will become 10 to the power 2, not minus 2. So here we'll get E naught minus 0.059. Okay, this is the only difference between E1 and E2, between the values of E1 and E2. So which one will be greater? E1 will be greater, right? And E2 will be less than E1. So we can say that E1 is clearly greater than E2. Okay, so let's see which of the options has this E1 greater than E2. In the option number B, we have E1 greater than E2. So option B will be the correct answer. Question number 64 is from the chapter Chemical Bonding and Molecular Structure. And the question is, which of the following pairs of compounds is isoelectronic and isostructural? Okay, so what is meant by isoelectronic? It means they have the same number of valence electrons. So let's write it down here, same number of valence electrons. And what is isostructural? So it's very simple, as the name suggests. It means they have the same structure. Okay. So here we have to find that pair in which both the species have same structure as well as same number of valence electrons. Okay, so let's check one by one. In the first pair, we have two species, TeI2, that is tellurium iodide, and ZeF2, xenon fluoride. Okay, so what is the number of valence electrons in tellurium? It is 6, and the number of valence electron in each iodine is 7. So for two iodines, we'll have 2 into 7. Okay, that is 6 plus 14. So the total number of valence electron in this species will be 20. Okay, 20 valence electron. And in xenon fluoride, we have Ze, that is xenon has 8 valence electrons. Fluorine has 7 each. So for 2 fluorine, 2 into 7. So here we get 8 plus 14, that is 22 valence electrons. That means they are not isoelectronic. Okay, not isoelectronic, because the number of this valence electron is not same. Okay, so this is not the correct answer. Now we'll come to the second one. Here we have I Br2 minus and Zef2. Okay, so Zef2, in the previous one also we saw it has 22 valence electrons. Okay, and in IBr2 minus, we know that iodine has 7. Each bromine will have 7. So for 2 bromine we have 2. So 2 into 7. Now plus 1, because it has 1 minus charge also. So total will be 7 plus 15, that is 22. So here we can see that both the species have 22 valence electrons. So yes, these are isoelectronic. Now we'll check whether they have the same structure, that is whether they are isostructural or not. So let's check. We know that to find the structure, we should know the hybridization. Okay, hybridization. And how do we find the hybridization? We use the formula half the number of valence electrons plus number of monovalent atoms minus charge on cation plus charge of anion. Okay, charge of anion. So for the first one, that is IBr2 minus, here we have half, then we have valence electron is 7 for iodine. Okay, iodine is the central atom here, right? So 7 plus monovalent atoms 2. Then we have no cation here, but we have an anion, so the charge on anion is 1. Okay, so plus 1. So here we get 5, and this 5 means that the hybridization is sp3d. Okay, and how will it look? It will look like this. This is iodine. We have one bromine here, one bromine here, and rest will be electron pairs. Okay, 2 electron pairs this side and 1 electron pair this side. So the 3 are electron pairs. The atoms are, the number of atoms are only 3. That means it is a linear molecule. Okay, like this. So the shape is linear. If we try to find the hybridization of the second species of this pair, that is ZeF2. So here we have half. What is the number of valence electrons in xenon? It is 8, right? So 8. Now there is no charge here, so the charge part will be 0. Monovalent ions will be 2. So 8 plus 2. Again we are getting what? Half into 10, that is 5. So again the hybridization will be sp3d, and here also, here we will have 2 bond pairs and 3 lone pairs again, similar to the previous one, and the shape will be linear. Okay, shape will be linear. So in this option, that is option B, the species are isoelectronic as well as isostructural. So B will be the correct answer. You can use the same method for the other two, and you will find that option C and option D are also not isoelectronic. Okay, they will not have the same number of valence electrons. So only correct option will be option number B. Now question number 65 is from the chapter Organic Chemistry, and the question is the IUPAC name of the compound. So this structure is given and we have to tell the IUPAC name. Okay, so let's draw this clearly. We have a hydrogen here, we have a carbon, we have a oxygen here, then we have a methyl group at this point. Again here we have a carbonyl group, then we have a double bond here, and then one carbon here. So if we mention all the carbons, then one, this is the first carbon, then here we have second, here we have third, here we have fourth, at this point we have five, and here again sixth one. Okay, so that means we'll write hex for this because six carbons are there. And then at the fourth position we have a double bond, so we can write hex 4-ene. And at the first position here we have an aldehyde group, so at last we can write it is 1-al. Okay, this is an aldehyde group. Now how many substituents are there? At second position we have a methyl group here. Okay, there we have a methyl group, and at the third position we have a keto group. Okay, so if we write alphabetically, first keto group will come and then methyl group. So first we'll write 3 keto and then 2 methyl. Okay, 2, here we'll write methyl. So we'll be writing 3 keto 2 methyl hex 4-ene 1-al. Okay, so which option should be the correct one? Here we have 3 keto 2 methyl hex 5-enal. No, not 5-enal, it is 4-enal. Okay, so option D will be the correct answer. Question number 66 is from the atomic structure, and the question is which one is the wrong statement. Okay, so we have to find the wrong statement out of the given 4 statements. The first statement says the uncertainty principle is delta E into delta T is greater than or equal to h by 4 pi. Okay, pi will be here on the lower side. Now let's check. We know that according to the uncertainty principle, the product of delta X and delta P is greater than or equal to h by 4 pi. Okay. Now we know that delta P is the change in momentum. So we can write it as m delta V, isn't it? And that will be greater than or equal to h by 4 pi. Now if we multiply and divide the left hand side by delta T, what will happen? Let's check. Delta X into m delta V, and we are multiplying it by delta T as well as we are dividing it by delta T. So there will be no change in overall value, but we'll get just another type of expression. Okay, here we have h by 4 pi. We know that velocity per unit time is equal to acceleration. So delta V by delta T will be equal to delta A, that is change in acceleration. So let's write it here. Delta X into m delta A, then delta T, and that will be greater than or equal to h by 4 pi. Also we know that mass into acceleration is what? Force, and then force into displacement will be equal to the work done or energy, because work and energy have the same unit. So force into displacement will be equal to energy, so we can write delta E, right? And here we have delta T, and that is equal to or greater than h by 4 pi. So isn't it the same expression that is mentioned in the first option, right? Therefore option A is the correct one, but we have to find out the incorrect one, right? So this will not be the correct answer because statement is correct. Now we'll check the second statement. It says half filled and fully filled orbitals have greater stability due to greater exchange energy, greater symmetry and more balanced arrangement. So this is absolutely correct statement again. We know that half filled and fully filled orbitals are more stable, and the reason mentioned is also correct because they have greater exchange energy, greater symmetry, and they have more balanced arrangement. Okay, so this is also not the answer because we have to find the wrong one. Then the third one says the energy of 2s orbital is less than the energy of 2p orbital in case of hydrogen like atoms. Now what do you mean by hydrogen like atoms? It means we have only one electron. Okay, only one electron is there. So what will be the electronic configuration? It will be 1s1 only, right? So there is no electron in s or p orbital, isn't it? That means the energy level of all the other orbitals other than this 1s will be same. So no one will have more energy or less energy. Therefore, this is a wrong statement. Therefore, we can say that this is the correct answer according to this question. Okay. Last statement says that de Broglie's wavelength is given by lambda equals to h by mv or h by p, where m is the mass of particle and n is the group velocity of the particle. Okay. So here it should be v, right? V is the velocity. So anyways, this is the correct expression for de Broglie's wavelength. So we can see that only one is wrong, and that is option number C. So option number C is the correct answer. Question number 67 is from solid state, and the question is, which is the incorrect statement? Okay, so again we have to find the incorrect one. The first statement says density decreases in case of crystals with Schottky defect. So this is a correct statement. Okay, this is a correct one. Why? What happens in case of Schottky defect? We know that in case of Schottky defect, ions leave the crystal, right? Ions leave the crystal, and due to this, mass will decrease, and when mass will decrease, the density will also decrease. So this is the correct one, but we have to find out the incorrect one, right? So let's proceed. The second statement says NaCl solid. Okay, so this is a solid NaCl, and that is insulator. This is the correct one because we know that NaCl will be acting as conductor when it is in aqueous form, not in solid form. Then silicon is semiconductor. This is also true. Silver is conductor. This is also true. And quartz is piezoelectric crystal. So this is also a correct statement. Okay, correct one. And we have to find the incorrect one. So we come to the third one. It says Frenkel defect is favored in those ionic compounds in which sizes of cation and anion are almost equal. So this is not true because we know that in case of Frenkel defect, there will be a size difference in cation and anion. Why? Cations should be very small, right? They should be very small, and anion should be very large as compared to the cations. Okay. Why? Because cations have to adjust in the voids. So in order to adjust in the small voids, they have to be very small. Therefore, there will be a size difference between them. They will not be equal. So this is the incorrect statement. Okay. Now, if we see the fourth statement, it says FeO.98 has non-stoichiometric metal deficiency defect. See, FeO.98 is nothing. It should be Fe.98O. Okay, this is the correct one. So if this would have been mentioned here, then this would also be correct, and C option would be incorrect only. Okay, but here I don't know if it is a printing mistake. If it is a printing mistake, then we can ignore this and option C will be the correct. If not, then both these statements are incorrect. Okay. Question number 68 is from the chapter Chemical Bonding and Molecular Structure. And the question is, the species having bond angles of 120 degree is. Okay. So what is the condition required for the bond angle to be 120 degree? The condition is that its hybridization should be sp2 and the shape should be trigonal planar. Okay. Trigonal planar shape. So we have to check the hybridization of the species in order to find the bond angles, right? So what is the formula to find the hybridization? We have seen in one of the previous questions that hybridization is equal to half number of valence electrons plus number of monovalent atoms attached, then minus the cationic charge plus the anionic charge. Okay, so here in all the options we can see there is no charge involved, so this charge on cation and anion will be 0. Okay, so this is of no use. Simply we have to find the value of half number of valence electrons on the central atom plus number of monovalent atoms attached to that. Okay, so let's check. First one is ClF3. Here the central atom is chlorine, so half the number of valence electrons on chlorine will be 7 plus how many monovalent atoms are attached to it? 3. Okay, so 3 here. So half into 10, that is 5. So what will be the hybridization? Here will be sp3d. Okay, that means it is not sp2. We need an sp2 hybridization. Okay, this is sp3d. Now we come to the second one. This is NCl3. Again we'll use the same formula. So half. What is the number of valence electrons on nitrogen? It is 5. How many monovalent atoms are attached to it? 3. So plus 3. So here we get half into 8, that is 4. So the hybridization will be sp3. Okay, again it's not sp2. Third one is BCl3, half. The number of valence electrons on boron is 3 plus how many monovalent atoms attached? 3. So half into 3 plus 3, that is 6. Half into 6 will be 3. For this, the hybridization will be sp2. Okay, total 3 orbitals. So obviously this is sp2, then the angle will be 120 degree here. Okay. If we check the last one, pH3. Here the number of valence electrons on phosphorus will be 5 plus 3 hydrogen, that is 3 monovalent atoms are attached. So half into 8, that is 4. Again here the hybridization will be sp3. So we have got the correct answer. Option C will be the correct answer because its hybridization is sp2. Therefore the bond angle will be 120 degree. Okay. Question number 69 is from the chapter Thermodynamics, and the question is, for a given reaction, delta H is equal to 35.5 kilojoule per mole and delta S is equal to 83.6 joule per Kelvin per mole. The reaction is spontaneous at, okay, assume that delta H and delta S do not vary with temperature. So at what temperature the reaction will be spontaneous? Now the condition for the reaction to be spontaneous is that the delta G value should be negative. Okay, it should be less than 0, then only the reaction will be spontaneous. Now we know that delta G is equal to delta S H minus T delta S, right? Now here for the spontaneous reaction, delta G should be negative. Okay, it should be less than 0. So this expression delta H minus T delta S should also be negative. Okay, so delta H minus T delta S will be negative for the spontaneous reaction. If we bring T delta S to the right hand side, we'll get delta H should be less than T delta S. Okay. Now we can bring delta S on the left side. So it will be delta H divided by delta S should be less than the temperature, because now we can relate it with the temperature. Okay. Or we can write that temperature should be greater than the value of delta H by delta S. So now here both the values are given. Let's put the values. Delta H by delta S value is 35.5 kilojoule per mole divided by 83.6 joule per Kelvin per mole. So here we have kilojoule, right? So we'll multiply it by 1000 to convert it into joule per mole. So we'll get, on solving this complete, we get 425 Kelvin. Okay. So here we know that temperature should be greater than this value. That means temperature should be greater than 425 Kelvin. Okay, because the value of delta H by delta S is 425 Kelvin. Okay, so according to that, option A should be the correct answer. Question number 70 is from the chapter Environmental Chemistry, and the question is, which of the following is a sink for carbon monoxide? Okay, so this is a very direct question. Options are microorganisms present in the soil, then oceans, plants and hemoglobins, and the correct answer is microorganisms present in the soil. Okay, so this is a very direct and very simple question, so answer will be option number A. Question number 71 is from the chapter Solutions, and the question is, if molality of the dilute solutions is doubled, then the value of molar depression constant, that is Kf, will be. Options are halved, tripled, unchanged and doubled. So we know that molar depression constant depends on the nature of the solvent only. Okay, nature of solvent. It does not depend on the concentration of the solution. Okay, and we know that molality is equal to number of moles of the solute divided by mass of solvent in kg. Okay, so molar depression constant has nothing to do with molality. So whether you double it or halved it, it will remain unchanged. Okay, so option C will be the correct answer. Question number 72 is from the chapter Solutions, and the question is, which of the following is dependent on temperature? Okay, so for that we have to remember that whenever there will be volume, that will be related to the temperature. Okay, that will be dependent on temperature. So let's see, in the first option we have molarity, and we know that molarity is equal to number of moles of solute divided by the volume of the solution in liter, right? So this is dependent on volume, and we know that volume will be dependent on temperature. So this quantity, that is molarity, will be dependent on temperature. Therefore option A will be the correct answer. Others are not dependent on volume. Mole fraction is the fraction of moles, right? Also weight percentage and molality also do not involve volume. Therefore, only correct option will be option number A. Question number 73 is related to surface chemistry as well as equilibrium. And the question is, which one of the following statements is not correct? So here also we have to find the incorrect statement. First statement says the value of equilibrium constant is changed in the presence of catalyst in the reaction at equilibrium. Now the first statement only is incorrect because we know that this equilibrium constant depends on the temperature only. Okay, equilibrium constant only depends on temperature. Okay, it does not depend on the presence of catalyst or anything else. So this is the incorrect statement. Let's see what the other statements say. Second statement says that enzymes catalyze mainly biochemical reaction. This is true. Okay, enzymes are those catalysts which catalyze the biochemical reactions. So this is a correct statement, but we have to find the incorrect one, which we have already found. Let's see, the third one says coenzymes increase the catalytic activity of the enzyme. Yes, this is also correct. And the last statement says catalyst does not initiate any reaction. This is also correct because we know that the role of catalyst start once the reaction has been started. Okay, then they speed up that reaction. They do not initiate the reaction, right? So only incorrect statement is A. Therefore, A will be the correct answer here. Question number 74 is from organic chemistry, and the question is identify A and predict the type of reaction. Okay, so on the reactant side we can see we have a benzene ring, then on the meta position we have a bromine, and here we have a methoxy. So this is nothing but M-bromoanisole. Okay, M-bromoanisole, and it is reacting with NH2, that is sodamide. Okay, so let's draw here again. We have a benzene ring. At the meta position, we have a bromine, and here we have a methoxy. Okay. Now it reacts with sodamide, that is NH2. Here sodium will have a positive charge and NH2 will have a negative charge. Now this negative part, that is NH2 minus, is highly reactive. Therefore, it will act as a base. Okay. Act as a base. Now what does a base do? A base removes the acidic hydrogen. Now where is the acidic hydrogen? It will be towards the group that is electron withdrawing. So oxygen is highly electronegative, therefore it will act as electron withdrawing group. Okay. Also bromine is highly electronegative, so this will also be electron withdrawing in nature due to minus I effect. So the hydrogen between these two will be the acidic hydrogen. That means hydrogen present at this position will be the acidic hydrogen. Okay. Now this base will remove this hydrogen from here. Okay, so this NH2 will take hydrogen from here and become NH3, right? And what will be left on the ring? Let's see. This is the benzene ring. Here we have methoxy group as it is. Here we have bromine as well. Now hydrogen has been removed, so here negative charge is present. Okay, and this NH2 has become NH3 now, ammonia. Okay, now what will happen? This negative charge can move towards the upper side or it can move towards the lower side in the ring. But since bromine is a better leaving group, therefore the charge will move downwards and bromine will be removed from here. It will leave the ring. Okay. So here what will happen? Bromine will leave. So what will be left here? Let's see. This is the benzene ring. Here we have methoxy. Now this negative charge present at this position has moved to this position, okay, downwards, and bromine has been removed from here. So this is the benzyl intermediate. Benzyl intermediate, which is highly stable in nature. So it will try to become stable. Let's draw this again here. OCH3. So this is what we had obtained at this place. Okay, benzyl intermediate. Now from here, this will try to become stable. This ring will try to retain the aromaticity. Okay, so for that, this bond, this electron has to move now. Now it can move either towards upper side or lower side. So where it will move? It will move towards the upper side now. Let's draw first, then we'll see the reason also. It moves at this position, okay, upper side, and the reason is that due to the electron withdrawing nature of oxygen, this will tend to be stable here, right? Now, since it has moved from this position, so here a positive charge will develop, right? Now it will further react with the ammonia. Okay. Now ammonia will have this plus charge on this hydrogen and negative charge on this NH2. Okay. So this negative amino group will get attached to this positive part. Okay. So let's see. This is the ring. Here we have OCH3. So at this positive part, the negative NH2 will join. Okay. And at this negative part, the positive hydrogen will join. Okay. So this is the final product. So what is the difference between this final product and the initial reactant? See, hydrogen was already there, methoxy was already there. Just in place of bromine, now there is an amino group. Okay, that means we can say that amino group has substituted the bromine. Okay, so first let's see which option has the correct product. We can see that in option number D, this is the product that we have obtained, and this is the substitution reaction because amino group has substituted the bromine group. Okay, so option D will be the correct answer. Question number 75 is from the chapter coordination compound, and the question is the correct order of the stoichiometries of silver chloride formed when silver nitrate in excess is treated with the complexes. So different complexes are mentioned here. This is the first complex, this is the second complex, and this is the third complex. Okay, so now these complexes will react with silver nitrate, excess of silver nitrate, and what will be formed as product? Silver chloride will be formed. So we have to find the order of stoichiometries of silver chloride that will be formed in each of the three cases. Okay. Now before starting that, we can see that all the complexes mentioned here contain 3 chlorine. Okay, 3 chloride ions. So the oxidation state of cobalt will be +3. Okay, because ammonia is a neutral ligand. Right. Now, what is the coordination number of cobalt? Coordination number of cobalt is 6. That means 6 atoms or ions can immediately surround cobalt. Okay. So what kind of geometry will be there? For 6 coordination number, it will be an octahedral geometry. Okay. So this is the basic thing that we know. Now let's start. The first complex that is mentioned is COCl3 6NH3. That means 6 ammonia molecules are there. Now if we write the coordination form, this is the coordination sphere. This is cobalt. Now, how many ammonia? 6 ammonia are there. So, NH3, 6. And also, the coordination number of cobalt is 6. So, maximum 6 can attach here. What is left? 3 chloride is left. So, that will be outside the coordination sphere. So, Cl3. Okay. Now, it will react with the excess of silver nitrate, AgNO3. So what will happen? This silver nitrate will extract this chloride from here. Okay. And it will form silver chloride. So what moles of silver chloride will be formed? 3 moles because 3 chloride have been removed. Okay. Now in the second case we have the complex COCl3 5NH3. Okay. It is mentioned in the question. This is the second complex. You can see we have 5NH3 here. Now again we'll write it in coordination form. So CO. Now 5 ammonia are there only in this case. So NH3 5. But the coordination number of cobalt is 6. That means one more can get attached. So one chloride will be here. Okay. Okay. Now how many chlorides left? 2 chlorides left. So these will be written here outside the coordination sphere. Okay. Now again it will react with excess of silver nitrate. This silver nitrate will extract these 2 chlorides from here and it will form 2 moles of AgCl because 2 chlorides have been extracted. Okay. Now in the third case we have COCl3 4NH3. Now again this time we have only 4 ammonia molecules. So cobalt, then 4 ammonia molecules will be there. But the coordination number of cobalt is 6. So 2 more can be present inside the coordination sphere. So 2 will be we'll take 2 chloride from here. Okay. 2 chloride. And how many chloride left? Only 1 left. So that will be written outside the coordination sphere. Now this time AgNO3 will extract only 1 chloride because only 1 is present here. Okay, so only 1 mole of silver chloride will be formed. Okay, only 1. So what is the order of stoichiometries? In the first one, 3 moles of AgCl was formed. In the second, 2 moles of AgCl was formed. And in the third one, only 1 mole of AgCl is formed. So the order is 3, 2 and 1. Okay. So in out of the given options, we can see in the second option we have 3 AgCl, then 2 AgCl and then 1 AgCl. Okay. So this is the correct order. So option B will be the correct answer. Question number 76 is related to organic chemistry, and the question is the correct statement regarding electrophile is. Okay, so the first statement says electrophile is a negatively charged species and can form a bond by accepting a pair of electrons from another electrophile. This is an incorrect statement because first of all, electrophile cannot be negatively charged. It can either be neutral or it can be positively charged. Okay. Also, it does not accept a pair of electrons from another electrophile. It accepts the pair of electron from nucleophile. Okay, so this is incorrect. Now we move to the second statement. It says electrophiles are generally neutral species and can form a bond by accepting a pair of electrons from a nucleophile. So the second part is true that it accepts a pair of electrons from a nucleophile, but it is not generally neutral. It can be neutral or positively charged. So this is not the most appropriate statement. Let's check another statement. The third one says electrophile can either be neutral or positively charged. So this is the most suitable one till now. Okay, and it can form bond by accepting a pair of electrons from a nucleophile. So yes, this is a most suitable statement. The last one says electrophile is a negatively charged species. Again, it cannot be true. It can either be positively charged or neutral. Okay, so the only correct statement is option number C. Question number 77 is from the chapter Thermodynamics, and the question is a gas is allowed to expand in a well-insulated container against a constant external pressure of 2.5 atmosphere from an initial volume of 2.50 liter to a final volume of 4.50 liter. The change in internal energy, that is delta U of the gas in joules, will be. Okay. Now, we know that the pressure mentioned here is 2.5 atmosphere. The initial volume, that is V1, is given as 2.50 liter. Then the final volume, that is V2, is given as 4.50. Okay, that is 4.5 liter. Now we have to find the change in internal energy, but first we need to find the work done. Okay, and we know that for an irreversible process, work done will be equal to minus P external, that is external pressure applied, into change in volume, that is delta V. Okay, that is minus P external V2 minus V1. Right, now let's put the values. P external is 2.5 atmosphere, so minus 2.5 atmosphere. V2 is given as 4.5 liter and V1 is given as 2.5 liter. Okay, that is minus 2.5 into 2 atmosphere liter. Okay, because 4.5 minus 2.5 is 2. So it will be equal to minus 5 atmosphere liter. Now we have to convert it into joule. So we know that 1 atmosphere liter is equal to 101.325 joule. Okay, so you should remember this. So minus 5 atmosphere liter will be equal to, will multiply minus 5 by 101.325. So that will be approximately equal to 505 minus 505 joule. Okay, so that will be equal to minus 505 joule. Now this is the work done, and what we have to find? We have to find the change in internal energy. Okay, so we know that from the first law of thermodynamics, the change in internal energy, that is delta U, is equal to Q, that is heat, plus the work done, W. Okay, now it is given in the question that the container is well insulated. That means no heat will be transferred. Okay, so the value of Q, that is heat, will be 0. So the change in internal energy will be equal to the work done, that is equal to minus 505 joule. Okay, so the correct answer will be option number B. Right. Now question number 78 is from the chapter amines, and the question is which of the following reactions is appropriate for converting acetamide to methanamine? Options are Hofmann hypobromamide reaction, then Stephens reaction, then Gabriel phthalimide synthesis, and the last one is carbylamine reaction. So the correct option is option A, that is Hofmann hypobromamide reaction. Okay, and this is an example of degradation reaction. Okay, degradation reaction. What happens? Let's see the reaction. We have an acetamide, right? So CH3 C double bond O NH2. This is acetamide. Now it is reacted with bromine and 4KOH. Okay, potassium hydroxide or sodium hydroxide. Okay, then we'll get CH3NH2, that is methanamine. Okay, this is the methanamine, plus the side products are potassium bromide or sodium bromide if we use sodium hydroxide. Okay, plus K2CO3. So if we use sodium, it will be sodium carbonate. If we use potassium, it will be potassium carbonate. Okay, but the main product is methanamide from the acetamide. Okay, so option A will be the correct answer. Question number 79 is from the chapter hydrocarbons, and the question is, with respect to conformers of ethane, which of the following statements is true? Option A, bond angle changes but bond length remains same. No, conformation does not change the bond angle or bond length. Okay, so both remain same. Bond angle does not change, so this is not true. Okay. Second one is both bond angle and bond length change. This is also incorrect because they do not change. Option C is both bond angles and bond lengths remain same. Now this is correct. Okay. Option D says bond angle remains same but bond length changes. Not true. Both remain same. Okay. So in case of conformation, the shape changes. Okay. Only shape changes, but there is no effect on the measurement of bond length or bond angles. Therefore, option C will be the correct answer. Question number 80 is from the chapter P block elements, and the question is, in which pair of ions both the species contain sulfur-sulfur single bond? Okay, so we have two species in which sulfur-sulfur single bond is present. First one is S4O6 2- and the second one is S2O3 2-. Okay, so in the first option only we have these two species, therefore option A will be the correct answer. Other options don't contain such pairs. Okay, so let's see the structure of these two species. First one is S4O6 2-, right? So here we have 4 sulfur and these are single bonds. Okay, sulfur sulfur single bond, then one more and then one more. 4 sulfur single bonds are there, and then this terminal sulfur will contain 2 double bonds with oxygen and one single bond with oxygen. Okay, similarly the last terminal one also contains 2 double bond with oxygen and one single bond with oxygen. Okay, now the structure of second one, that is S2O3 2-. So its structure looks like this. We have only 2 sulfur here and these contain single bond between them. Then we have 3 oxygens here like this. Okay, and we have 2- charge. So these are the structures of these species, and option A will be the correct answer. Now question number 81 is again from the P block elements, and the question is, it is because of the inability of Ns2 electrons on the valence shell to participate in bonding that. Okay, so see, this inability of Ns2 electrons of the valence shell to participate in bonding on moving down the group is known as inert pair effect. Okay, it is known as inert pair effect. So this effect is what the question is asked about, right? Now, as a result of inert pair effect, what happens? First of all, lead 2 Pb2 is more stable than the lead 4. Okay, it's more stable than Pb4. It means the +2 oxidation state is more stable than the +4 oxidation state. Okay. Now, what does it mean? It means that lead will easily be reduced from +4 to +2. Okay, lead is reduced. It will be reduced from +4 to +2 oxidation state because +2 is more stable, right? Now, if it is reduced, then it will act as what? Oxidizing agent for others. Okay, therefore, it acts as an oxidizing agent because it itself is getting reduced. Okay, so it is oxidizing in nature. Now if we talk about the tin, okay, Sn, so the case with tin is just the opposite. Here Sn4 is more stable. Okay, Sn4 is more stable than Sn2. It means that +4 oxidation state is more stable than the +2 oxidation state. So in this case, what will happen? Tin will be oxidized. Okay, tin is oxidized. It will be readily oxidized from +2 to +4 oxidation state because +4 oxidation state is more stable. Okay, now it is getting oxidized. That means it will act as a reducing agent. Okay, therefore it acts as a reducing agent for others. So from here we can see that lead 4 plus is oxidizing agent because it is getting reduced itself, whereas tin 2 is reducing in nature. Okay, so the conclusion is that lead 4 plus, it is getting reduced to lead 2 plus, right? That means it is oxidizing in nature, and Sn2 plus is getting oxidized, so it is reducing in nature. Okay, I hope you got this. So the correct option will be the last one. Sn2 plus is reducing while Pb4 plus is oxidizing. Okay. Now question number 82 is from the chapter coordination compound, and the question is correct increasing order for the wavelengths of absorption in the visible region of the complexes of cobalt 3 plus is. Okay. Now here we should know that for stronger ligands, the energy of the light absorbed will be more. Okay, energy will be more, but the wavelength of the light absorbed will be less, right? That means as the ligand gets stronger, its energy will increase, but its wavelength will decrease. So we can say that the strength of the ligand is inversely proportional to the wavelength. Okay, so first we'll arrange them in increasing order of the strength. Okay, so out of the given options, the strongest ligand is the En, and then ammonia, and then water. Okay, so what will happen to the wavelength? The series of wavelength will be, see, the wavelength will be minimum for En because it is the strongest one. So En, then ammonia, and then water. Okay, so this will be the increasing order of the wavelengths of the light absorbed in case of these ligands. Okay, so first En, that means uh, this one. Okay, last option, then ammonia, and then water. So option D will be the correct answer. Question number 83 is from the chapter aldehydes, ketones and carboxylic acids, and the question is consider the reactions. So different reactions are shown here, and we have to identify the compounds A, X, Y and Z. Okay, so the reaction starts with the reactant X, whose formula is given as C2H6O. Now this formula shows that X is either an alcohol or an ether. Okay, so what happens? This X reacts with copper at the temperature 573 Kelvin to give a compound A. Now we don't know what this compound is. Now what happens? Here onwards, three different reactions are taking place, giving three different products. Okay, so in the first reaction, what happens? This A reacts with Ag, NH3, 2 plus ion, and then silver mirror is observed. Silver mirror is observed. Now this is a very important indication because we know that silver mirror is observed in case of Tollens test, where an aldehyde reacts with ammoniacyl silver nitrate to give silver mirror. Okay, so this is quite clear that A must be an aldehyde here, then only silver mirror will be observed. Okay, so A is an aldehyde, that is sure. So let's check in the given options. In the first option, A is methoxymethane, that is an ether, so this is not true. In the second option, A is an ethanal, that is an aldehyde, so this is possible. In the third option, A is ethanol, that is an alcohol, so this is not true. And the last one, A methoxymethane, again not true. So the only possibility is that option B will be the correct answer because here only A is an aldehyde. Okay, now let's check what is the compound X. So X was the initial reactant and it reacted with copper at 573 Kelvin to give the compound A, right? And A is an aldehyde, that is ethanal. So this is ethanal and X must be an ethanol then. Okay, ethanol, that is a primary alcohol, because we know that ethanol on reaction with copper at 573 Kelvin, it will give ethanal. Okay, so now X is ethanol. In option B, you can see X is given as ethanol. So this is also true. Now we'll check for Y and Z also. Let's see, Y is obtained in the second reaction. What happens? This A is heated in a basic medium. Okay, it is heated in a basic medium in this second reaction to give the compound Y. So let's check what will happen when ethanol will be heated in basic medium. So let's write down the reaction here. Ethanol, that is CH3 CH double bond O. So it will react with another ethanol molecule, right? So CH2, I'm writing CH2 and H separately so that I can show the reaction here. Okay, then CHO. Now oxygen from one ethanol molecule and hydrogen H2 from another ethanol molecule will come out as water molecule. Okay, so basically dehydration will take place and what will form here? A formation of double bond will take place. So CH3 CH double bond CH, then CHO. Okay, and what is this? This is but2-enal, because 4 carbons are there. So 1, 2, 3, 4, and at second position we have a double bond. So but2-enal. Okay, so Y should be but2-enal. Let's check if it is given in option B. Yes, Y is but2-enal. Now we have to check for Z, that is the last one. So in the third reaction, it is reacting with NH2, NH, C double bond O, NH2, that is hydrazine. Okay, so let's write down the third reaction here. We have A, that is ethanol. Okay, so ethanol CH3 CH double bond O, it reacts with NH2. Let's write down H2N here so that reaction can be shown. H2N, then NH, C double bond O, NH2. So this is hydrazine. And what will happen? Similar reaction will take place, that is oxygen from aldehyde and H2 from the hydrazine will be removed as water molecule, and again the formation of double bond will take place. So let's write down the product here. CH3 CH, and then this side double bond N, NH, C double bond O, and NH2. This will be formed and this is known as semi-carbazone. Okay, semi-carbazone. So this Z should be semi-carbazone. Okay, this is the compound Z. That means option B is correct because here all the compounds are mentioned correctly. So option B will be the correct answer. Now question number 84 is again from the chapter aldehydes, ketones and carboxylic acids. And the question is, of the following, which is the product formed when cyclohexanone undergoes aldol condensation followed by heating? Okay, so let's draw the cyclohexanone molecule first. We have a cyclohexane ring here. Then we have a keto group here. This is cyclohexanone. Okay, now we know that there will be 2 alpha hydrogens at this point and there will be 2 alpha hydrogens at this carbon as well. So what will happen? This is the medium and we have OH minus ion in the medium. This OH minus will take up one of the hydrogens from here. Okay, it will take up one of the alpha hydrogens. So due to the removal of hydrogen, there will be development of negative charge. Okay, let's see. This is the hexane molecule. This is the cyclohexanone. Now, one of the alpha hydrogens has been removed from here. So there will be a negative charge at this point. Now what will happen? This will react with another cyclohexanone molecule. Okay, so this is another cyclohexanone molecule and this negative charge will attack on this ketonic carbon in order to form a bond with this molecule. Okay, so let's see. This is the first molecule. Okay, and this is the second molecule, isn't it? Now at this point, since this negative charge has attacked at ketonic carbon, so this bond will move towards the oxygen. Okay, So in the second molecule, there will be only one bond with oxygen and there will be a negative charge on this oxygen, okay, because the charge has moved on the oxygen and there has been a formation of bond between these two molecules, okay. So now what will happen? Let's see. There will be H plus ion also in the medium, right? There will be, let's draw this again. This is the first molecule. This is the second molecule. In the first molecule, there was a keto group here. In the second molecule, there was single bond with oxygen and a minus charge, okay, and there was a bond formation between these two molecules. Now, there will be H plus ion also in the medium. So this negative charge will now take up this H plus ion, okay, and it will form OH. So what will be formed? Let's see. This is the first molecule. Then this is the second molecule, okay, and here the oxygen has taken the hydrogen and made OH, okay. Now what will happen? There will still be one alpha hydrogen at this first molecule, okay, one has been removed and one alpha hydrogen is still there. So now dehydration will take place, okay, or condensation will take place and this will be removed as water molecule. So there will be a formation of another bond, so double bond will be there, okay. So this is the first molecule with a keto group. Now a double bond has been formed between these two molecules because another alpha hydrogen has also been removed. Okay. So this is what the final product will look like. Okay. That means there will be two cyclohexane molecule. At one of the cyclohexane molecule, there will be a keto group and there will be a double bond between these two molecules. Okay. So according to that, which option should be correct? Option number A. Okay. Option number A is the correct answer. Now question number 85 is from the chapter Chemical Bonding and Molecular Structure. And the question is, which of the following pairs of species have the same bond order? Okay. So how do we find the bond order? We know that bond order is equal to number of electrons in bonding molecular orbital minus number of electrons in anti-bonding molecular orbital divided by 2. Okay, so we'll use this formula to find the bond order of each of the given species. Okay, let's start with the first option. Here we have the species O2 and NO plus. So for O2 we know that each oxygen atom consists of 8 electrons, so 2 oxygen atoms will have 16 electrons. Now let's see how these will be distributed. So sigma 1 is 2, then sigma star 1 is 2. Star means anti-bonding, right? Then sigma 2 is 2, then sigma star 2 is 2, then sigma 2pz2, then pi 2px equals to pi 2py. That means these have same energy level, okay, so 2 electrons each. Then anti-bonding, that is pi star 2px equals to pi star 2py. Now only 2 electrons are left, so 1 in each. Okay, now how many electrons are there in bonding molecular orbital? Total 10 electrons. Okay, and in anti-bonding molecular orbital there are 6 electrons divided by 2. That means 4 divided by 2, so the bond order is 2. Okay, so O2 has bond order 2. The another species of this pair is NO plus. Now we know that oxygen has how many electrons? 7. Oxygen has 8. That means 15, but plus charge is also there, so minus 1, that is 14. Okay, now let's see what will be the bond order. So sigma 1 is 2, then sigma star 1 is 2, then sigma 2 is 2, then sigma star 2 is 2, then pi 2px 2 equals to pi 2p y2. Okay, then sigma 2p z2. Okay, 14 electrons done. Now how many in bonding? There are 10 electrons in bonding molecular orbital and 4 only in anti-bonding. Okay, divided by 2, that means 6 divided by 2, so there are 3. Okay, that means the bond order is 3. So we can see that in this pair the bond order is not same for O2 and NO plus. That means option A cannot be the correct answer. Okay, now we'll check for option B. Here we have Cn minus and CO. Okay, so let's check. In option number B we have Cn minus and then we have CO. So let's see How many electrons in C? That is carbon. We have 6 electrons. In nitrogen we have 7. So 13. But minus charge is also there. That means plus 1. So how many? 14 electrons. Okay. Now in NO plus also, in the previous option we had seen that there were 14 electrons and the bond order was 3. That means here also the bond order will be 3 because it also consists of 14 electrons. Okay. In CO, carbon will have 6 and oxygen will have 8. How many? Total 14 electrons again. Then again the bond order will be 3. Okay, that means in this pair the species have same bond order. Okay, that is 3. So we can say that option B is the correct answer. Similarly, you can check for option C and D also. They will also not have the same bond order. So the only correct answer will be option number B. Question number 86 is from the chapter General Principles and Processes of Isolation of Elements, and the question is, extraction of gold and silver involves leaching with cyanide ion. Silver is later recovered by. Options are distillation, zone refining, displacement with zinc, and liquation. And the correct option is option number C, that is displacement with zinc. Okay, so let's see how this is done. Suppose we have to extract silver. So we'll have the compound that contains silver, then it will made to react with the cyanide ion. Basically we use sodium cyanide. Okay, so what will be formed? A water soluble compound complex will be formed which will contain AgCN2 minus ion. Okay, and then this will made to react with zinc. Okay, so let's see, we have AgCN twice minus ion. Okay, and it will react with zinc in order to recover the silver. So silver, solid silver will be obtained and Zn CN4 2 minus ion will be formed. Okay, so we can see that zinc has displaced silver. Okay, so basically what has been done? Displacement has been done. Okay, so displacement with zinc will be the correct answer. That is option C will be the correct answer. Question number 87 is from chemical equilibrium, and the question is, a 20-liter container at 400 Kelvin contains gaseous carbon dioxide at pressure 0.4 atmosphere and an excess of strontium oxide. The volume of the container is now decreased by moving the movable piston fitted in the container. The maximum volume of the container when pressure of carbon dioxide attains its maximum value will be. Okay. Now it is given that this reaction is taking place in the container. So let's write down this reaction again. We have strontium carbonate that is in solid state. Okay. Then it is dissociating into strontium oxide, again solid, plus gaseous carbon dioxide. So what should be the Kp of this reaction? The Kp should be equal to the partial pressure of carbon dioxide gas only, because strontium oxide and strontium carbonate are in solid state. So the partial pressure will be taken as unity. So we'll consider only the partial pressure of carbon dioxide. Okay, that means Kp should be equal to the partial pressure of carbon dioxide, and it is given that the Kp value is 1.6 atmosphere. That means the partial pressure of carbon dioxide is 1.6 atmosphere. Okay, that means it will be the final pressure of carbon dioxide. Okay, but initially what was the pressure of carbon dioxide? It was zero point 0.4 atmosphere. So we can say that P1 was equal to 0.4 atmosphere, but P2 is equal to 1.6 atmosphere, right? P1 was 0.4 atmosphere and P2 is 1.6 atmosphere. And what was the initial volume of carbon dioxide? It was given as 20 liter. But we don't know the final volume, and that we have to find out, right? Temperature remains the same throughout the process. That means the process is isothermal. And we know that in case of isothermal process, for isothermal process, the product of pressure and volume will remain constant. Okay, that means P1 V1 will be equal to P2 V2. So from here we can find out the value of V2, right? P1 is equal to 0.4 atmosphere, V1 is equal to 20 liters, P2 is equal to 1.6 atmosphere, and V2 is unknown. Okay, so 0.4 into 20 will be equal to 8, divided by 1.6 will be equal to V2. So on solving this, we'll get 5 liters. Okay, So the correct option will be option number D. Okay, final volume of carbon dioxide is, the maximum volume is 5 liter. Okay, so option D is the correct answer. Question number 88 is from the chapter coordination compound, and the question is pick out the correct statement with respect to MnCN6 3-. So we have to find the correct hybridization and structure of this compound out of the given options. Okay, so let's find out the oxidation state of manganese first. Let's assume this is X. Now for each cyanide ion it will be -1. So for 6 cyanide ion it will be -1 into 6, and that will be equal to the overall charge, that is -3. Okay, that means X minus 6 will be equal to -3. So what will be the value of X? It will be -3 plus 6, that is +3. That means manganese is in its +3 oxidation state. So what will be the electronic configuration? Electronic configuration of Mn3 plus is equal to that of argon and then 3d4. Now let's draw the orbitals here. This is the 3D orbital. So we have 1, 2, 3, 4, 5. Okay. Then this is 4s orbital. This is 4p orbital. Okay. Now we have 3d4. That means 4 electrons in 3D orbitals. 1, 2, 3, 4. 4s and 4p orbitals are completely empty. Okay. Now the ligand here is cyanide. That means strong field ligand is present. So due to the presence of strong field ligand, due to the presence of to the presence of strong field ligand, pairing is possible. Okay, pairing is possible. So let's see what will happen after pairing. This is the 3D orbital. 1, 2, 3, 4, 5. Okay. Then we have 4s, that is completely empty, and then 4p, again completely empty. So one pair will be formed here, and then these two will be single. So we can see that two 3D orbitals are empty now, and 4s and 4p are completely empty. Now we have 6 cyanide ions here, so it will form coordinate bonds here. So one cyanide ion in this, one cyanide ion in this 3D orbital, one cyanide ion in this 4s, right? And again 3 cyanide ions in each of the 4p orbitals. So how many cyanide? 1, 2, 3, 4, 5, 6. Okay, so 6 cyanide ions will form coordinate bonds in these orbitals. That means 2 3D are occupied. That means 2 3D are used, 1 4s is used, and 3 4p is used. Okay, so what will be the hybridization? Hybridization will be D2, because 2 d orbitals are used, then 1 s orbital is used, and 3 p orbitals are used. So D2sp3. Okay, and the shape will be, or the structure will be octahedral, because 6 ligands are there. Okay, so the correct option will be option number B, D2sp3 hybridized and octahedral. Okay, so option B is the correct answer. Question number 89 is from DNF block elements, and the question is the reason for greater range of oxidation states in actinoids is attributed to option A, actinoid contraction, option B, 5F, 6D and 7S levels having comparable energies, option C, 4F and 5D levels being close in energies, and option D, the radioactive nature of actinoids. And the correct answer is option number B, that is 5F, 6D and 7S levels have comparable energies. Okay, so there is minimum energy gap between these three levels, and due to that electron excitation is easier. Okay, let's write down here minimum energy gap, and due to this electron excitation is easier. Okay, excitation is easier, and when electron excitation is easier, then in that case there will be greater range of oxidation states. Okay, greater range of oxidation states. So option B will be the correct answer. And now the last question is from the chapter biomolecules. And the question is, which of the following statements is not correct? Okay. So we have to find the incorrect statement. The first statement says oval albumin is a simple food reserve in egg white. So this is a correct statement. Okay. But we have to find the incorrect statement. So let's move to the second statement. It says blood proteins thrombin and fibrinogen are involved in blood clotting. Again, this is a correct statement. Now the third statement says denaturation makes the proteins more active, which is not at all true, because we know that during denaturation the helix get uncoiled. Okay, protein helix get uncoiled, and due to that protein loses its biological activity. Okay, protein loses its biological activity, and therefore it is said that protein gets denatured. Okay, so it does not become more active, it becomes less, in fact not at all active. Okay, it becomes inactive. So this is the incorrect statement. So option C will be the correct answer. But still, let's see what is option D. It is saying that insulin maintains sugar level in the blood of human body. So we know that this is a correct statement again. So the only incorrect one was option number C. Okay. So here we complete all the chemistry questions from NEET paper 2017. We'll be back with another session soon. Till then, keep learning, keep scoring high. For a better understanding, I would suggest you to practice same questions from the website www.examsnet.com, and for more information you can download our app from the link given in the description. Thank you.